Hello, good morning to all of you. This is a doubt clearing session as well as attendance. Please join with us. Those who have joined here, if there is any doubt about that video lecture about recursion, please start asking the questions. Is there any doubt about recursion? Good morning to all of you. Acha, one thing in your live chat session, one picture is coming on the left hand side of every name, but some maximum of you have no picture. Without profile picture, you are not allowed from this coming week. Beware of that. Debojyoti Lodh, sir, Fibonacci series. Do you? What is your question? I will not tell you the how do you implement Fibonacci series with the help of C language with recursion, but you don't know about Fibonacci series, then I can tell you. Probably your question is about the Fibonacci series. Fibonacci series means Fibonacci series is Fn. Fn nth term can be expressed as the previous term fn minus 1 plus fn minus 2. Now you see this nth term is depending on the just two terms. So how many initial values will be needed? Definitely initial values will be needed. F0 is equal to 0 and F1 is equal to 1. These are the starting numbers. So what should be F2? F2 is equal to 0 plus 1, that is 2. That means the sequence will be 0, 1, 1 plus 0, that is 1, 1 plus 1, 2, 2 plus 1, 3, 3 plus 2, 5, 5 plus 3, 8, and in this way you can print out. So up to nth term, that is if you have to print n number of Fibonacci numbers with the help of this recursive equation, right? Whether you can do this or not. This is Fibonacci series. Okay, the Bojiti, is it clear? Possibly after this you can write with the help of recursion. Okay. Hoshik Sarkar, does recursion somehow take more computation time than loops? The question is not clear to me. Actually, for loops means by iteration. Better you can tell the definitely iteration will help you efficiently to solve to find the n number of Fibonacci numbers, right? And the question is very nice. If you want to find out the nth term by recursion, actually, if I cannot remember the number, if you want to find this F100, possibly F100 or F200, possibly your 2 GB RAM will not give you the result, because that 200 that recursion will actually, the recursion behavior will be exponential. That I will tell you the analysis of this thing. That will take at least 1 hour time to give you the analysis of this. The behavior of finding 200 number in a Fibonacci series, it is exponential, truly exponential. But if you do it by iteration, that means if it can be done by bottom up approach, that means 0 and 1 is there. If you want to find out F200, then first find out F2, then F3, then F4. In this way you can find out F200. This is called iteration, right? But recursion means you are calling F200 directly. Then you are coming, you see this, I'm giving you the example. Your question is right, but don't use loop iteration. You see this, suppose F4, for finding F4, what is needed? F2 and F3. You see this, for finding F2, what is needed? F0, F1. For finding F3, F2, sorry, F1 and F2. And for finding F0 is F0 equal to 0, you know this, 0, and F1 is equal to 1. These are the last two first base terms, and F1 is equal to, here it is 1. And what is F2? F2 is again F0 and F1. Now you see this. What is this? Here F2 is calculated and here is also F2 is calculated. That means so many sub functions, sub problems will be there. Those are overlapping. I mean, every time, if you can store F2 somewhere, then you can call this again and again. But in recursion, it is not possible. Every time when you are calling F2, the some stack memory will be reserved for this calculation. That means so many. That means if you want to find out F200, can you remember how many overlapping subproblems are there? And this is basically a tree structure. You see this here. The children of F is this, and every node have two childs. That means here it is 2 power 0, here it is 2 power 1, here it is 2 power 2, here it is somewhere 2 power 3, like this. And if you want to find out 200, it will be 2 power 200. It is truly exponential, and so many overlapping sub problems will be there. Every time you are actually, you can see that F2 can be calculated so many times. But as The computer is a store and forward procedure device. So if you can store F2 or some F5 value somewhere else and it can be reused several times, then it will be better. And it can be done only by the iteration. But in recursion, it cannot be done. That's why recursive procedure will blow out the full memory if it is sufficiently large Fibonacci number. It's clear? That's why recursion will not give you the better. You can find out the to a 10th Fibonacci number, a 20th Fibonacci number. The question, Oshik Sarkar, the question is very nice. Do you understand, Oshik? Please tell yes or no. Arpan Odhikari, if we perform binary search using recursion while the time complexity being log n order, I cannot get you that. I want to, if we perform binary search using recursion while the time complexity be, yes, you see, recursion will not uh, change the time complexity of the algorithm, but for recursion the more spaces will be needed because every function calling will reserve an extra memory space, right? So here you see this for F4 there is a stack memory reserved, and this F4 function will be calling F2 and F3. So for F2 one space will be reserved and for F3 one space will be reserved. That's why space will be more, but analysis is same, right? For every algorithm, recursion will not change the complexity behavior of your designed algorithm, but it will take more spaces, right? Arpan, is it clear? It is log and order. Is it clear, Arpan? Acha, who have asked the questions, please tell me if you understood. Yes, Arpan, thank you. Any more questions? If between two questions there is a 1 minute gap, then I will end the live stream. Okay, please ask questions. As it is a pre-recorded video and it has been posted yesterday, the questions should be ready. Arpan's question is very nice, and also Oshik Saka's questions also was also very nice. Any more questions? I don't know whether some of you have asked any questions, but I And I am telling you, Ishik Sarkar, recursion for Fibonacci series will take more computational time than iteration, right? For Fibonacci series, not for all. And for every problem, if there is a concept of overlapping sub problems, then only recursion behavior is more or less exponential, right? Does it take? Yes, it's more time. Definitely more time. You just Oshik, just you take. Acha, Arpan Adhikari, I will take care of this thing offline because it is not the part of this course. What is tailed recursion and non-tailed recursive functions? I think all of if you are more familiar with the algorithms in your class 11, 12 level, right? So I will take care of you. You can just mail me in soman.nandi@imcal.com, then I will tell you what is tailed recursion and non-tailed recursive functions, right? But yeah, Ushik Sarkar sir, does it take more time? Does it take more time means Fibonacci series, right? Right. That you see, because you see this for finding F4, F2 is calling 2 times. If you want to find 200, how many times it will be called? You don't know this. The behavior is, that I have told already. 2 power 0. Here you see this in this level 2 power 0 element are there. Here the function calling is 2 power 1. Here the number of function calling is. You see exactly like here function calling is f1 f1. This is also repeated. 2 power 2. In this level it is 2 power 3. Right. So if it is 200, then it may be 2 power 200. So you don't know. That means if the iteration is there, then the algorithm's complexity is order of n, because you have to traverse 0, 1, then this is 1, it is coming from this plus this, again this plus this will give you 2. So nth element can be found in order of n by iteration, simply using a loop. But if you want to do by recursion, then as for the overlapping sub problems, it is a sub problem because this is a function call. Function calling means it is a sub function. So there are so many sub problems will be overlapping sub problems will be there. That means same function will be calling more times. That's why its behavior is exponential. So the complexity will be increased. Oishik Sarkar, right? It, yes, it will take more time, Oishik Sarkar. And Devjit Banerjee, sir, if recursion is memory intensive, then why do we still use it? No, no, no. There, you see, recursion actually somewhere recursion will be needed for solving some problems. But some problems cannot be solved by iteration, and there are some problems it can only be solved by recursion. But for this problem, overlapping subproblems are there. Clear? And there, if you apply binary search with the help of recursion, then there will not any no more overlapping subproblems will be there, because the first problem is the whole list. Just consider the binary search problem. First problem is the whole array, and it will be subdivided into say left part and right part according to the middle element. And this left part and right part, there is no relation between the left part and the right part. All the elements are purely disjoint. This set and this set are disjoint. That means no complexity will be, time complexity will not be increased by using recursion, but it can be done very efficiently using recursive method, right? That will help you to write the code efficiently. right? So there, if no overlapping sub problems will be there for a given problem, that you have to analyze, right? There are so many problems where overlapping sub problems will be there, like this, and there are problems where every sub problems are purely disjoint. It may be the case, depending on the problems, right? Then its behavior is very nice with the help of recursion. And you can tell if the space is not a issue or not an issue, then you can use recursion always. Okay. So definitely recursion is memory intensive because space will be needed for every function call. Some more spaces will be needed, right? Is it clear, Ushik Sarkar? Are you happy with my answer, Ushik? I want answer from you. Actually, Ushik, recursion is basically a recursive. It is also a function, but the special thing is it's a function called by itself. But and every time that I have told in the video that every time you are calling the function, this called function for called function, some memory will be reserved, and it will return the value to the previous function. That means there must be a stack. For recursion, stack will be used. That is the application of stack here actually. So by writing recursion, that can be taken care by the compiler, taken care of by the compiler. That stack, right? Of the stack can be used. Okay. Thank you very much to all of you. I think no more questions are there. Just do the assignments and give the IMCRP test. I am leaving now from the live stream. Okay. Thank you.